Okay, hi everyone, my name is Mia and this is my astronomy telescope presentation. I'm doing my presentation on the South African Large Telescope, which is also known as SALT for short. So SALT is located in Sutherland, South Africa, which is in the Northern Cape Province. It has a diameter of 9.2 meters and it's the largest optical telescope in the Southern Hemisphere. It's also known as Africa's giant eye on the sky, and the map you can kind of see is just where it's located in South Africa. So a brief history: the South African Government Science Agency built SALT with the help from Germany, India, New Zealand, Poland, the UK, and the United States. The construction of SALT costed approximately 36 million USD, which was funded by all of these international partners. The telescope took 5 years to build, and the president of South Africa at the time opened the telescope with a ceremony on November 10th, 2005. Now, going more into the actual how the telescope works and an overview. As you can kind of see in this image, it got kind of cut off, but SALT collects light from astronomical objects and accurately focuses it to one of 4 focus points. That light then proceeds into an optical instrument, and then the telescope can track that movement across the sky to maximize exposure time. SALT overall is optimized to collect light from extremely faint and distant astronomical objects, including as far as different galaxies. Observations from SALT have contributed to the understanding of dark energy, which can be defined as a mysterious force accelerating the expansion of the universe. And the location of this telescope makes it possible for researchers to analyze objects that can't be seen from just within the Northern Hemisphere, which is very valuable. Some more concrete features of the telescope. SALT has an unusual mirror design, which is fixed at a 37-degree angle, and that angle is a fixed zenith angle, which allows the telescope to access a larger section of the sky. The actual mirror details: its primary mirror is composed of 91 hexagonal segments, which are all 1 meter wide, and they work together to form this massive reflecting surface. And there are 2 separate mirrors that form together to create one giant mirror that is 36.4 by 32.2 feet in size. Okay, some fun facts and the overall impact that SALT has had. This telescope can see objects 1 billion times too faint with the naked eye, and it has and still continues to provide detailed spectra of distant galaxies and has contributed to the discovery of new exoplanets. A smaller fact is that every 2 weeks, mirrors are removed, cleaned, and recoated with aluminum, which I found interesting because it seems kind of time-consuming. But now moving into the impact part of things, SALT has had a very positive impact not only on astronomy, but also on students and careers. So during the construction of SALT, the SCBP was established, which is the SALT Collateral Benefits Program, which was basically established to make it so society can benefit off the construction of this large telescope, which I think is positive because it is such an expensive project and there is so much room for learning and projects and career development. So the focus points from this being created was education in areas such as mathematics, technology, science, communication, and awareness, and even to public engagement. And this has been very, very successful. It's been able to reach over 700,000 people, all from learners to teachers and even to public outreach. So I think that's a positive thing to note. That is all I have. Here are some references, and thank you so much for listening.